Welcome back, mathematicians. In this video, we are going to look at another example where we're solving a quadratic equation by using the quadratic formula. So let's start by reminding you of what the quadratic formula is. It is x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. So we have a quadratic equation of x squared minus 4x plus 2 equal to 0. So the first thing is we notice that it's equal to 0. So there's no simplifying, there's no moving parts around or terms around. So it's exactly in the form that we want it to be. Next, let's identify a, b, and c. So a is the leading coefficient of your x squared. So that would be 1. B would be the coefficient to your linear term, that would be negative 4, and C is going to be your constant, which is positive 2. Let's now substitute these values into the formula. So we will get x is equal to opposite of b, that would be positive 4 because it's the opposite of negative 4, plus or minus the square root of b squared, which is negative 4 quantity squared, minus 4 times a, which is 1, times c, which is 2, all over 2 times a, which is 1. Now let's simplify the expression under the radical. So that will be 4 plus or minus the square root of negative 4 quantity squared. Very important that we use parentheses there because there is a difference when you have the parentheses versus when you don't and you're squaring a number. Negative 4 quantity squared is going to be 16 minus 4 times 1 times 2. So it's negative 4 times 1 times 2, which is negative 8 or minus 8, all over 2 times 1, which is 2. Now let's continue to simplify. So we're going to take 16 minus 8, so that'll be 4 plus or minus the square root of 16 minus 8, which is 8 over 2. Now you might think we're done at this stage because we have the square root of 8, and we don't know the exact value of the square root of 8, meaning it's not a perfect square. But we can still continue to simplify this expression. We need to simplify the radical of the square root of 8. I'm going to do that off to the side here. So square root of 8 is really equal to the square root of 4 times 2. Now the reason I broke it up into 4 times 2 is because the square root of 4 is an exact integer. We know exactly what it is. It's a perfect square. I'll continue to break this up by taking the square root of 4 times the square root of 2. And we know the square root of 4 is 2, and there's nothing we can do with the square root of 2. So let's take that and replace the square root of 8 with that term. So we have x is equal to 4 plus or minus 2 times the square root of 2, and that's all over 2. Okay, continuing over here, I am now going to try to reduce this fraction by a common factor. So we need to look at the numerator and say, is there a common factor of 4 and 2 times square root of 2? And the answer is yes, there's a factor of 2 that is in common. And I'm going to factor that out. Now when you factor that out, you're really dividing both the terms by the 2. So 4 divided by 2 is 2. And when you take 2 times the square root of 2, divide by 2, you just are left with the square root of 2. If you want to check yourself, you can always redistribute this 2 back into that expression, back into the 2 plus or minus square root of 2, and you should go back to what we had just a step ago. And then we have a denominator of 2. Well, that means that we have a common factor in the numerator and denominator of 2, and this can be reduced by that common factor, so that our final answer is 2 plus or minus the square root of 2. All right, guys, good luck.